Bismillahirrahmanirrahim. October 2022, variant 43. And the topic is particle, link particle. So particles. So let's see how we can do it. Car, the mass is 1750 kilograms. Is pulling a caravan of the mass is this. Okay. So the car and caravan are connected at a tow bar. The resistance to motion to car and caravan are this much given. So we have to find out what with a constant speed, when it's the speed. So acceleration is confirmed 0. And we need to find out the power of the engine on the car. Okay, okay. What's the formula? We have to do it. Basic formula we use is net force equals to MA. Though they are connected, so let's see how we can do it. So, and first you mentioned that horizontal motion. Okay, I give you an example to understand. So it is not hard, inshallah. Diagram will make easy. Car. Okay, and they are connected. So whenever we need only like a power or something like that, okay, so we will never take tension. We can, this is applied force. Okay, and we can think about it. Okay, and this is a friction acting backwards. Friction acting backwards. Friction on a car is 650. And friction acting on a car one is 150. Okay, I think clear. Now I can say, students, what is the basic formula? Net force is equals to MA. Because constant acceleration A is 0. So I can say applied force minus friction force equals to 0. And what is the force formula? Power is equals to F into V. If I bring this under it, so V becomes power by, wait a minute, power. So F is equals to applied force equal to power by V. So I'm using it now here. And friction force goes there. And power is unknown, speed is 24. But which friction you talk about? Both. You also why, sir? Because they are behaving, they are connected particle. The burden on the car is both together. Both friction is will be added here. So I'm adding 150 plus 650. And 24 multiplies there. After multiplying, the answer turned to be 19200 watt. Or I can say approximately or not 19.2 kilowatt. And this is my answer number 1. So let's talk about next part. This AI done. A2, engine power is now changed, increased to 40 kilowatts. So engine power. So power is turned to be 40,000. Okay, and the instance find acceleration and the tension. So I said before many times, whenever we have a two variables to find, okay, then we have, and 5 marks especially, so we have to solve them simultaneously. So now situation is same situation we have, but this time, okay, I make another diagram for it. But because this time we have to find out acceleration and tension, so this is applied force, which is 40,000. 40,000. Sorry, this not force, sorry to say, this is a power, this power. Force, I will find it. Okay, and this is our two particles are connected. And now I'll make it two tensions towards each other. And now if it is a friction acting backwards, is a friction on a car 650. And this is a friction on caravan is what? Is 150. Clear. Now let me check anything else behind. I think nothing. So I'm going to make two equations. This is this three forces on one and these two forces on one. I'll make two equations. But first of all, because you know this 24 speed is acting under same, so I will find out easily. And what is the basic formula? We have it. We have used even here this formula. So what is the force? Is a power 40,000 divided by 24. Applied force is turns to be 40,000 divided by 24. I get a 120 I'm getting actually fraction number. Okay, I'm writing in fraction for more accuracy. 5,000 divided by 3. So now I'm going to make it now for this is a car. So for car, I will make equation here. So what I can say, applied force is equal to 0. Not 0, sorry, capital F minus friction of car minus tension equals to MA. What is F? I have found 5,000 by 3. And what is the friction on car? 650. Tension unknown. Mass, how much? Mass of the car is 1750 times 2A. Now, if I check it, this is coming with me in fraction form is 3050 by 3 minus tension equal to 1750 acceleration. Now I'm going for the second. Caravan. Okay, so again, I will use this one, net force equal MA. I'll start from here and this one. So tension minus 150 is equals to MA. And what is the mass? 500. So this is a formula. I think if I do one thing, I write it, this formula I'm bringing down here. So look at students, this is copy and paste. So I'm going to solve it and tension will cancel out. And these two value I'm solving. And let me check. Minus 150. I get a fraction value again left side. I got a 2600 by 3. On the right hand side, I got a 1750 plus 500. And I got a 2250 acceleration. So 6600 divided by 3 divided by 2250, and my acceleration is coming with me 3 point. Just let me check again. 3 point acceleration is 3.47. Okay, so yes, for the typing error only. This is all correct. Okay, the typing this answer is 0.385 meter per second square. I have done it, and now students, I'm going to plug in this value in the and above equation. For example, this plug in it here. If I type in calculator, so tension is coming with me 343 newtons. So Alhamdulillah Rabbil Alameen, this part is clear. Now let's talk about B part. So he's saying that car and caravan now travel up the hill with angle is given here, and horizontal constant speed. It means acceleration equal to 0, and car engine is working this much now. Okay, so it means students. I will erase this one and look, and I'm going for this another value. So what is the power of engine is 31000, and unknown speed is this one. This is actually what is the formula? Applied force power by V. So this is applied force basically. Okay, so now what situation we have? The resistance to motion of caravan unchanged. Okay, and we have to find it. So now what to do? I think it is a very clear approach. I will take this diagram and I'm going to finish the question. So check it, please. No need to make it other tensions because I'm going to find the other simple criteria, simple value. Okay, what is this applied force? I got it, 31,000 over V. 31,000 over V. 31,000 over V. Okay, frictions are not changing. So I can say here, and constant acceleration, constant, because he said constant acceleration 0. So I think we can get it easily. Let's try to do it. But sorry to say, this is a inclined on angle now. Inclined on angle. So, okay, it means we have diagram change now. So story is change. And I have to make another diagram. The story is, okay, I just keep it here alone. Okay. And 1 minute, I have to complete it. So I'm going to, okay, look at now students, because we're going up, hold on, let me check again, traveling upwards. So we can make the diagram here. So we have to make a long diagram so to understand easily. Okay, now this time this is a car. This is as I said before, 31000 by V. Okay, and now this is a second part. Okay, and this is a friction, and that is a 650. And this is a weight, mg sine theta. Okay, this is a friction, that is 150, and this is a weight component. Okay, now angle is very clear given here. Okay, students. So first of all, what is our mass mg sine theta? Because we have given this one, so this is given by him. So I can take alpha is equal to sine inverse 0.14. It will go there. So sine alpha is equal to 0.14. So this I can use 0.14. So mg sine theta is equal to this one. So mg sine theta. So m is what? 1750. 1750 into 10 into 0.14 into 0.14. So student, when I type this in calculator into 0.14, so I'm getting 2450, 2450. So this is weight component, this weight component 2450. Okay, newtons. Now we're to find the same story, the other one student. So mg sine theta mass 500. So I'm using here 500. So 500 and one more zero into 0.14, and I'm getting 700. So this is a 700. Now, so I can do it easily. So I can say net force equal to MA. So 31000 over V minus friction minus weight component of the car minus friction and minus weight component of the other is equal to 0. Why? Because that is because constant, you know it very well, constant speed. And now I will bring the all component on the right side, 650 plus 2450 plus 150 plus 700. I get what, students? 3950 and 31000 by V. So if I divide 31000 divide by this, so answer is turns to be 7.85 meter per second. I hope so. The concept is completely over and question is completely finished.